neutral injection. It has to pass through the neutral because, of course, it's a single step. So therefore, whatever position is going to be in before, it has to go through the center point to get to the other side. So if we just zoom in, here we can see that we have the center point. So as I said, the control signal to the pilot valve, moving our pilot spool, allowing a flow of, we can see that we have the pilot valve, get a signal from the control system to the pilot spool, allowing a flow of control oil to the underside of our control piston here, moving and maintaining the position of our main piston in the center point, so we have no working pressure to either the exhaust valve actuator or the fuel booster, so we are just maintaining the center point here. And then we are, of course, then draining from the exhaust valve actuator and the fuel oil booster. When we are ready to do an injection, we would then get a signal to the pilot valve, and then the control oil pressure will go to this side of the main spool, forcing the control spool against the main spool, forcing it upwards. Therefore, you can still now see that we're still draining from our exhaust valve actuator. And then we're going to do an injection here. So we have closed the drain port here with this bevel. So therefore, we are giving an injection. When we've done an injection, we have to go through the center point. So we come back down, still draining from the exhaust valve actuator, and now we are then again draining from the fuel oil booster. Then we're going to get a signal to do an exhaust valve operation. So you can see now we're going to get a full downward movement of the main spool, moving down, still draining from the exhaust valve. Still draining from the fuel oil booster, and now we're going to have the pressure to the underside of the exhaust valve actuator, giving us a full operation. Signal from all movements all the time is being sent to the control system from the feedback sensor mounted here. The feedback signal being sent, and the system is checking every half a millisecond to ensure that the main spool is in the correct position no matter the time. Okay, so that's half a millisecond to check the correct position. Any questions to do with that? Nope. Okay, let's see if this works. Now I'm working on my own, gentlemen, so bear with me with my really crap camera techniques. Everyone see the FIVA?
Still the same screen.
Okay. What about now?
Yes, sir, we can see.
Can you see a hand?
Yes, sir.
Okay, that's my hand. Good. This is a FIVA valve. All we've done is just cut it out so we can see the inner parts of our FIVA itself. So the block, on the back side, we would have the control valve. There is not a control valve mounted because, of course, it is just for show. And we can see here that we have the ports I was talking about. So for the fuel injection, exhaust valve operation, and the pressure here. And then we have our pressure ports to the exhaust valve actuator and the pressure port for the fuel booster. Okay. If you can't see anything, just let me know and I'll try and adjust the camera movement. Like I said, I am working on my own, so it's a little bit difficult. So you can see here, if we look in now, that the control spool is not attached to the main spool at all. Can you see that, gents?
Yes.
So, yeah. So the pressure coming in, I don't know if you can see it very well. Can you see the hole at the back?
Yeah, the hole with the groove, right?
Yeah. So you see that the hole, can you see this hole here? There's a hole in the back there. That's one of the ports where the controller will come in. Yeah. That's one of the that's where the controller will come in to move the, again, I apologize for the camera, gentlemen, the control spool here backwards and forwards, okay, to maintain the main spool in whatever position is required. So now we have the main spool in the center moving out. Then you can see here we have the pin, which is Loctite glued to the main spool, and it is the pin that is moving in and out of our feedback sensor shown here. So if you did take the feedback sensor off, this pin would still be in here, and then that would be susceptible to possible damage because we don't want it bending. We have seen it before, and that's why we say we do not want you guys to change the feedback sensor yourselves. So if you can just about see in here, we have a control spool. We have a smaller piston. If I can just get there. This is one of 4 pistons here. This is to give us the downward movement of our main spool for the exhaust valve opening. Okay. Okay, so you can see that the 4 smaller pistons and the control spool is not attached to the main spool. Okay, you can see if we get close enough, the tolerances, if I can just, now this is an old one, it's quite worn, a little bit of rust on, but you can just about see the tolerance. You can see how close the housing and the main spool are. We're talking thou of millimeter, and then we can also see these grooves on the moving parts. These grooves are to trap oil for a smooth movement in the FIVA housing. Okay. Are there any questions so far? Nope. Okay. From yesterday, when we were looking at the hydraulic unit events, we were discussing about the movements and the position of the FIVA. So what we have here is we have a center position now. So I'm draining from, you can see that my my pressure port here is closed off. So there's no oil coming out into either the pressure port for the booster or the pressure port for the exhaust valve. So we are, as you can see, draining from the underside of our exhaust valve actuator and the underside of our fuel booster. So in the center position, so no fuel injection and no exhaust valve operation. So a signal is sent to the FIVA valve that we are going to do something called a prepare to inject. Now, when we're doing a prepare to inject, we need to get the main spool right on the edge. So we're not doing an injection. We're just getting this main spool in position so there's no delay for the injection. And we still can see that we're draining from the exhaust valve actuator here. And now we're getting ready to inject. So we have a prepare for injection, then we do an injection, and then it moves to the injection point, bang, and that's where it stays. And then when the injection is done, bang, back to the center point. Okay, so it's instantaneous. Yeah.